Hi, this is Nathan Tintle. In this Learning Goal video, we will talk about the validity conditions for a theory-based test on a regression slope. We'll use the heart rate and body temperature data set to talk about this learning goal. The theory-based test is a t-test for this type of data where we're testing two quantitative variables and we're evaluating regression and correlation. There are three validity conditions for this theory-based t-test for regression. We'll talk about those three validity conditions now. The first validity condition says this, that the general pattern of the points in the scatter plot should follow a linear trend. The pattern should not show curved or other nonlinear patterns. We've talked about this before when we've said it doesn't make sense to fit a best fit line and compute a slope or compute a correlation coefficient if the underlying pattern of the data is not linear. For this data set, we do see a generally linear pattern, that is, as we increase body temperature, heart rate tends to increase in a fairly linear way on average. Second validity condition, there should be approximately the same distribution of points above the regression line as below the regression line. That is, we should see symmetry around the regression line, and we do see that here. We see a similar pattern of points above the line as we do below the line. And finally, the third validity condition says the variability of the points around the regression line should be similar regardless of the value of the explanatory variable. That is, we don't see a lot of spread around the regression line in some places and less spread other places. Here we see a fair bit of variation around the line, but that's pretty constant no matter what the body temperature is. A few words of caution. As with all validity conditions we've seen before, these are rules of thumb. That is, you say, well, how much asymmetry in the distribution or how much change in the variation is needed? Well, it's a bit of a judgment call. If you're not sure, what should you do? Well, do the simulation test and see if you get a similar size p-value as you do with the theory-based test. That's one way of evaluating and confirming that, in fact, the validity conditions are okay. You also may wish to consider variable transformations, not something we talk about in this class, but by, say, taking the log of the data. Sometimes that can help when you have extremely skewed data and can help your data meet validity conditions.